Hi, my name is Dinesh Thakur. I am a research staff at the GRASP Lab and I work with Dr. Vijay Kumar. Today I'm going to show you multiple micro-aerial vehicle or robots showing a formation flight, or you can think about forming different shapes in the air. By formation we mean like circle, line, different shapes that you see a swarm of robots that can fly. The robot that we are showing in the demo, it's a research platform. It was developed in-house. It's a around 250 gram micro aerial vehicle. We call it micro, which are like lower than 500 grams. There's bigger robots which fly also we have in the lab, but this ones we categorize them as micro scale. It's a quad rotor, so it has 4 rotors and motors, and so it's used to fly. The cost of such a research platform currently would be at around $1,000 to $2,000. Given that it's a research platform, it's slightly higher, but once you commercialize it, we have seen commercial drone in this size and form factor around $500. If you have seen drone shows out in outdoors, most of them rely on GPS. So here we do not use GPS, neither do we use motion capture system. All of these drones rely solely on the onboard cameras and the processor, which is a cell phone grade processor equivalent to a Samsung Galaxy S5. So running single MAV or robot itself is challenging, and right now with this project what we are trying to show is a single operator can run multiple of this. You don't need like one operator per robot. In India, the schooling system is slightly different. So around high school time, you have to kind of choose what subjects you focus on. If you want to do engineering and medicine are the two main prominent areas that people, at least the parents, push their kids towards. So based on that, you have basically two options. You either focus on the engineering or maths and science courses or the biology courses. And I was leaning towards engineering because I used to try to tinker around with toys and stuff and other engineering tools. That's when roughly I said, okay, I'll just focus on the engineering side of it and try to get in engineering. So here we send each of them to a certain height. All of these robots have a camera which is facing downward, and they try to see the tag that is on the ground, which is called an April tag. You can think of April tag as a fiducial tag or a barcode which can tell each robot its pose or its location with respect to the tag. So the reason to use the tag is to get a reference for each robot, since each robot doesn't know where the other robot is. So if each robot can see this tag, in a way they can know the other robot's position with respect to each other. That allows this formation to be formed. So once everything is a go, I'm going to send them in a formation flight. So here for the demo, we're just going to send them in a line firstly. Now the line is formed with respect to the tag, where the center of the tag. We can move the origin of the line back and forth. Another formation that we can easily do is arrange them in a circle with the center being the tag again. We can move the center of the circle forward and backwards or any other place with respect to the tag. Again, we are sending them in the line here, and then again this is just a repeat of the whole demo again, over and over again. So each of these robots uses a downward facing camera to track the features on the ground, and also they use something called an inertial measurement unit, which is IMU, which kind of tells the robot how fast they are moving or how fast they are accelerating, and also tells roughly where the gravity, Earth's gravity, is pointed towards. So this gives them a frame of reference to fly and estimate their position with respect to the ground. My uncle was more kind of a mentor that way, so he always made us do things just push the boundaries and try to do different things and not just focus on one thing. The battery life of these robots is roughly 7 to 10 minutes. We can definitely add a bigger battery and get a better flight time. This is a research platform, so we haven't optimized the weight of the robot to get a longer battery life, but commercial robots like this, which you can buy off the shelf, can run up to 30 minutes. Since we use this for research and development, we haven't spent enough efforts on trying to optimize the battery life, runtime of the robot. So they use battery which are lithium polymer. The reason to use lithium polymer is they allow for large discharge rate of current. As you can see, each of the propellers draws a lot of current, and having lipos, if you use your regular batteries, they cannot provide that much amount of current in burst of current in short amount of time. So the processing on these robots is done on board. There's nothing running on my laptop. All I'm sending is to where to form the formation or shape. It's using a cell phone grade processor, something equivalent to a Samsung Galaxy S5. Imagine if you have a cell phone on each of these robots for doing its processing. There's no external computation currently. Micro-aerial vehicles or aerial vehicles in general have shown great potential in first response, in search and rescue, and aerial surveys, photography in general. So what you can do with one robot now, if you have multiple robots, it increases the area that you can cover. There is more resilience to failures with multiple robots. Other applications you can think of, multiple robots allows for nicer photography. Now imagine if you are shooting a movie or video or general photography, you can have multiple different angles and viewpoints, and you can dynamically change them and look at the same object from these different views. So that's a huge current application. Further applications can be inspections of dams and buildings can be done pretty easily. So imagine the small robot going in tight spaces. So you can think of first response or search and rescue, sending them in damaged buildings after earthquakes or some disaster scenario is one application. So I went to college in Dubai and I majored in electrical and electronics engineering. So after my undergraduate, I joined Penn for my master's in robotics, and that's when, while doing my master's, I was introduced more to the research while working with Dr. Kumar's group in the GRASP lab. Classes and activities for being focused on engineering in high school, definitely there's maths and science, but also in addition, just in general, for me in certain areas in design was art. So it's not just always science and math, I believe personally. There's other areas which can come in to help you down the line. Another application that we have been working in a lab is trying to see Wi-Fi signal strength. As you know, all of you would know how Wi-Fi signal drops or is choppy around different buildings or even in your rooms. So one project with Comcast that we are doing is try to see how map the Wi-Fi signal strength. So if imagine two robots going around a room, and we can test the Wi-Fi connectivity between two robots, and this will help the designers place the routers in exact locations so as to improve the overall Wi-Fi performance. Getting over a little bit of intimidation, I think initially just like reading and learning more, self-learning was something I did more. So anything that I didn't know, I would just spend more and more time trying to understand it by myself. And once I got a grasp of that area or expertise, then I would be less intimidated about doing more research. Research is very open-ended, and you don't really know where things are going to lead to, so you just have to find answers for yourself in general.